Okay, so in the previous video, we learned, right, how to draw the graph by looking at their basic shapes and also by applying the concept of transformation of graph. Okay, so in our syllabus, generally, if you know all the 5 types of the basic shapes and also how to transform the graph correctly, it will be enough for you to answer the question for the domain and range for A-level syllabus. All right. So of course, in this world, there are many types of different functions. Okay, so of course, we not able to learn all the graph for all the function, but for A-level syllabus, graph method is enough for us, okay, to answer. And then for algebraic approach, usually we'll apply this one maybe in higher level maths, right? Because for algebraic approach, it can be used to answer many types of questions, okay, that involve the domain and range, but you need to know a lot of things. So you have to know a lot of the characteristic of the equations and so on. That only you can apply the algebraic approach. There are many special cases, right? So that's why we only focus on the graph method for our syllabus here. Okay, so I hope that you already at least have the idea how we actually transform all the graph and how to sketch the graph. Okay, and now for all the example that we are going to discuss now, I want to focus more on how to sketch the graph and also how to get the domain and range from the graph that you draw. All right, okay, so let's have a look here. Let's start with the linear functions. So linear function means that your line, the equation is slope, a line slope, okay? So the general form will be y equals to mx plus c. Okay, so usually when you want to sketch the straight line, you need to find the value for x-intercept and y-intercept, okay? Or maybe according to the values of the domain given, right? You can actually substitute the value, okay, by using the edge of the domain given. Okay, so we can have a look for 2 examples here. All right, so if let's say you want to test whether you really understand about all the concept or transformation that we learned before or not, you can actually try to pause the video first and then you complete examples first and you come back only to check your answer and also listening to the explanation if let's say you cannot get the answer correctly. Okay, so let's start with example 3. Okay, so for this example 3, they want you to graph and also write down the range. All right, so for part A, you didn't see any domain given at the end, right? So usually when there's no domain given at the end of the function, generally it is understood that x is any real number. When they didn't write up, so we will assume that x is from negative to positive infinity. Okay, all right, so to sketch 2x plus 1, you let x equals to 0. All right, so your y is equals to 1. And then if you want, you can let also y equals to 0 and your x is equals to negative 1 over 2. Okay, then you try to sketch your graph, 1 and negative half. Okay, so maybe 1 is here, maybe the negative half is here. Okay, so when you sketch a graph, it will look something like this. Okay, so this is a line y equals to 2x plus 1. So this is x and this is y. All right, so from here you can see that your graph will keep on drawing, okay, down and also keeps on drawing up. All right, okay, so can I know what is the range for the graph here? So the range, the graph, because will keep on going up and keep on going down, so the whole part of the y-axis, all the value for y-axis belongs to the part of the graph. So that means your range is what? Right, so for this one, the range when you write out, it will be, you can write like this, the range of function, it is y can be any real number or y is an element of real number. Okay, so this is what we have here. Right, okay, now how about for part B? So for part B, okay, they give you the function here. And after that, they want you to focus on this domain only. The domain is from negative 1 until 3. So when the domain is given in a specific range, then usually when you want to find out the value, okay, so maybe when you want to actually you can substitute the value for negative 1. So you're having negative 1 plus 2, you get a 3. And also you can substitute the 3 into the function, and then what do you have is negative 3 plus 2, and therefore you get negative 1. So when you try to sketch the graph, okay, so the x value is from negative 1 until 3. And then for the y value also from negative 1 until 3. Okay, so when you want to plot the graph, that means this is the graph, negative 1, 3, and also 3, negative 1. All right, and then you try to join these two lines together. Okay, all right, so from here you can see very clearly that when you draw the graph, your graph is from this value from here until here, which is from negative 1 until 3. Okay, and for the y-axis, you are looking for the range, you are looking for the y-axis. So for the y-axis, you will see that the value is from here until here, right, the range. And therefore, when you want to find out the range, what's the value? So you can write the range of function is y. Okay, so you can write it become negative 1 until 3. Or you can write it like this. Bracket, square bracket, negative 1 until 3. Okay, so we would like to talk about the square bracket here. So the square bracket here means that the value taken is from negative 1 until 3 and it is inclusive. Okay, that's why you have the equal sign here, equal sign. If your y is like this, not include the negative 1 and 3, then when you want to write out in the bracket form, then it will be a round bracket, negative 1 and 3. Okay, these two have the same meaning for the range. All right, so if you feel that it's very confusing, right, you just use the symbol correctly. Okay, that got equal sign one, it should be a square bracket. No equal sign one, it should be a round bracket. Okay, so after you sketch the graph, then roughly you will know, okay, you try to figure out what is the correct domain and what is the correct range. Graph. All right, so this is the purpose that we want to discuss this part, so that you know how to draw the graph, at the same time you know how to look at the range from the graph. All right, okay, so this is first pattern when you are having the linear function. So to get the domain and range for linear function, generally it is not hard. It is quite simple and straightforward actually. All right, okay, and now let's continue to part number 2. How are you going to find the domain and range for quadratic function? So usually for quadratic function, I will tell students, if can, you try to completing square, because from the completing square, you will know that what is the shape. And then you will know also what is the location or what is the coordinate for minimum point and also maximum point. And then from there, you can sketch a quadratic curve, quadratic graph, and after that, you may get the domain or the range that they want you to get. Okay, so this is one method. Another method is you use a transformation of graph. So transformation of graph means that you start sketching x square first, and then maybe after that you change it become x plus 3 square or whatsoever. You follow the steps and then you get the graph also can. All right. But no matter how, completing square is a pattern that you must have, no matter which method you want to use. Because completing square will straight away give you the minimum or maximum point coordinate, which is very, very convenient for us to find out the range. All right. Okay, so let's have a look for example 4. Okay, so for example 4, first part, they want you to express this function into a completing square form. Okay, so for part 1, I'm not going to show you the steps. Please make sure you do it yourself and try to get the answer. So the answer for part number 1, it should be x minus 3 over 2 squared, and then minus 9 over 4. All right, so this is what we have. Okay or not? And then after that, we go for part number 2. Okay, so they want you to write down the range of f. Okay, write down. So that means they just want you to write out the answer. If you do the completing square correctly just now, okay, so from here, this is a positive value, right? So from here, you know that it is a U shape. Okay, And from here, you will know that the minimum point, okay, the coordinate will be 3 over 2 and also negative 9 over 4. All right, so when you want to sketch the graph by looking at the completing square form, then generally how will it look like? It will be at 3 over 2 here and then negative 9 over 4. So I will assume that this is negative 9 over 4 and then this is 3 over 2 and it should be a U shape. So I will just put it like that. But of course, the graph that I'm sketching here might not be the very accurate one because I didn't check what is my y and x coordinate, intercept, sorry. Okay, so I just simply draw. I know that it is a shape and the smallest value, the minimum coordinate will be 3 over 2 and negative 9 over 4. Okay, so if you want it to be more accurate or the graph to be nicer, then you can try to find out also the x and y intercept. So to find the x-intercept, you let y equals to 0. To find the y-intercept, you let x equals to 0. Okay, for me, I don't think that it is needed. All right. Okay, so after I sketch a graph, then I look at the domain. What is the domain that they want us to sketch a graph? So from negative to positive infinity, that means my graph will continue draw from left to the right. So this is my graph radius, the whole graph. Okay, so I want you to write down the range of f. So to get the range of f, you see what is the smallest value of your quadratic equation. And then the graph will keep on going up. So the range will cover from upper until this value. Okay, so to write out the range, what is the range for this answer, for this question? So the range will be y greater equals to negative 9 over 4. Okay, so this is actually what we have. All right, so again, you actually need to have a graph and look at the domain given in the question to sketch your graph. After that, only you decide the range. Okay, so I hope that you understand this. All right, and then in exam, right, the word write down, usually for the word write down or state, they actually don't require you to show them the steps. All right, so that means for this particular question, if you are very clear that how the graph of the quadratic look like, then you can straight away write out the answer without sketching the graph. So for the sketching graph part, generally is a method to help you to visualize what do you have only. So some students no need to draw the graph, and they also know they already have the graph in their mind. So you can straight away write out the answer, also no problem. Understand what I say or not? So although we learn how to sketch a graph, but it is mainly to guide us for our own understanding. All right. Sometimes they will ask you to sketch, but not often. Okay, so usually all the steps, all the graph sketching is to help us, okay, to visualize the graph ourselves to get the range. So if let's say you know how to sketch it in your mind, right? No need to sketch it out. Okay, imagine it in your mind, and then you can write out the answer straight away. So the answer is y greater equals to negative 9 over 4 plus. But again, please make sure that every time when you draw the graph, please refer to the domain given in the question. All right. Okay, so let's have a look for example 5. Okay, so for example 5, the function defined as x squared minus 3x. So if you compare it with example 4, these two are actually the same. Okay, so these two are actually the same. All right, so maybe I will write out my completing square here first. So again, as what I mentioned, if you want to know the range, the best way is you still need to write it in the completing square form. So x minus 3 over 2 square minus 9 over 4. Okay, so now let's have a look for the answer here. Okay, so I'm still using the graph here. All right, I'm still using the graph here. Okay, so for example 5, part 1, if the domain for the graph function is x smaller equals to 3, write down the range of f. Okay, so your domain now is only for x smaller equals to 3. And they want you to know to write out the domain. Okay, so how can you do it? All right, so for example 5, part 1. Because the age of the function here, the domain here is 3, right? So maybe I want to know if I substitute the 3 into the function, what is the value that I will have. Okay, so when you substitute the 3, you'll get a 0. That means what? That means this is actually the 3. When you substitute the 3 into the function, you'll get a 0, right? So this is the coordinate 3, 0. And for this question, they are asking for the graph with the domain x smaller equals to 3. So if you have x smaller equals to 3, what kind of graph that you should draw? Okay, you should only consider the purple color graph. Okay, that means this is only the graph that you should consider because this is the domain for x smaller or equals to 3. Understand what I say or not? Smaller or equals to 3 means on the left-hand side of the 3, right? Left-hand side. Okay, so the left-hand side of the 3. So the right-hand side graph, you should ignore it. Okay, so if now you are having this kind of graph, okay, how to get the range? Sorry. So again, the smallest value of the graph is still the same, which is -9/4, and your graph will keeps on going up, right? Okay, so the range will be the whole part, okay, above the -9/4. Therefore, for part number 5, the range is still having the same answer, which is y greater equals to -9/4. All right, okay. So if you compare example 5 number 1 and also example 4, both answers are the same, but the graph that we draw is different. Okay, so in part 4, in example 4, we draw the whole U shape. All right, but for now, 5 number 1, we only have this part of the graph that we want to consider. But if you look at the graph again, the smallest value is still -9/4. All right, therefore the range, it is still greater equals to -9/4. All right, then after that, if no problem, then we continue to part number 2. If the domain for the function f now is x greater than 5, write down the range of f. Okay, so instead of 3, now they want to consider only the graph for x greater than 5. Okay, although the 5 has no equal sign, but I want to know what is the value for the 5 here. Therefore, I still substitute the 5 into my function. So you're having 5 squared minus 3 times 5. Therefore, you get a 10, value of 10. Okay, so when you get a value of 10, again, now you still refer to the graph one more time. Okay, so I draw. Original graph is something like this, right? Okay, so just now you already know that this is 3 lah. So when you substitute 5, okay, so that means when x equals to 5, let's say this is a 5, okay, so this value itself is a 10. Okay, so what kind of graph they want to consider? They consider the graph for x greater than 5. That means they only want to consider the graph for this part only. Will keep on going up, right? Only for this part. That means this is not the graph that I want. Okay, all right, so your graph will look something like this. Okay, so now what the range for the graph? So again, now the smallest value of the graph on the y-axis is here and keeps on going up, right? Therefore, for part number 2, the range is y greater than 10. Can you see that or not? So example 4 and 5 actually shows you that different domain will give you different graph and also different range. So you have to be very careful when you want to find out the range. And the exam again, all the graph that I shown you just now, you no need to purposely draw it out. If let's say you can imagine it in your mind. But if you cannot, then better you draw it out so that you can refer to the graph and then you write out the range correctly. Okay, example 6, this is another example. So first part, they ask you to find out the fx in completing square, and after that they want to state the range of f. Okay, so if you want, then maybe now you can do the completing square yourself lah. So the answer for completing square is 2x minus 2 square plus 3. Okay, so what is the range? So the range of answer will be y is more than or equals to 3. So these are the answer. Okay, so what kind of method you want to use it? Again, you can use the completing square method to sketch a graph, and then you get the range from the graph. Okay, so maybe for now, I want to show you how to use the transformation to sketch a graph. Because we just learned the transformation in the previous video, right? So maybe you can attempt and see how can we complete it by using the transformation. All right, okay, so now this is my final graph. Okay, and then the domain that I need to draw is x can be any real number. Okay, so I will start. So first, to use the transformation of graph, I know that the basic graph is x squared. So what is x squared here? So it will be U shape. All right. Okay, then next one, you want to draw x minus 2 and then the whole thing square. So when you put a negative inside your basic shape, what will happen? You need to move your graph how many units? 2 units to the right. So you have this, and then this will become 2. Okay, so this is the second stage. After that, the third one, you need to sketch 2 times. You multiply 2 outside your graph. So when you multiply 2 outside your basic function, what will happen is your graph will become slimmer and taller. It is still the 2. It is still the 2, right? So it becomes slimmer and taller means that maybe it looks something like this. Okay, all right. But no matter how this and this, right, the shape is still the same. Because if you didn't compare, then you cannot see the difference, right? So if you want to compare, then the new graph here will become slimmer and taller. Okay, and after that, you need to plus 3. So plus 3 means what? You need to move your whole graph 3 units up. So when you move your whole graph 3 units up, the 2 is still the 2. The original 0, you have to move it up, become 3. So your U shape will become something like this. Okay, so this is a 3. And then from this graph, final graph here, you will know that your graph keeps on going up, and therefore your range is y greater equals to 3. So this is by using the transformation knowledge we learned. Okay, so if you're lazy, then this is what you can use. Completing square, straight away draw the graph from completing square, and then you get the range. So see which one you prefer. Alright, so in the exam, they will not fix any method for you. So because they are not asking you to sketch all the graph here. So all these are for your own understanding only. Alright. Okay, so I hope that you understand for this part. Quadratic equation is the questions that they usually like to ask for the domain and range. So please make sure that you are very clear about the quadratic function. Okay, then now let's continue. The next type is cubic functions. For cubic function, generally, right, they seldom ask us one, because usually for cubic function, the domain and range will be usually the real number. Therefore, they seldom ask us about the cubic function. But of course, you still need to know how to sketch it out, okay, how to sketch a graph correctly according to the domain and so on. All right, then next one, we go for the rational function. Okay, so for rational function, okay, we learn the one only. So the basic one will be 1 over x. The graph will look something like this, and we discussed it in the previous video already, right? And also how to draw the transformation of all the graph here. Okay, so like this one, they write the domain. X can be any real number, but x cannot be 0. And the way that we write out is x can be any real number except 0. So except is this one and then 0. Both are accepted. Okay, so they are teaching you the algebraic method. So that means when you see the rational function, at the denominator you have x equals to x minus 5, right? So you make it become x equals to, not equals to 5. Something like that. All right, again, for me, I will still ask you to sketch a graph by using the concept of transformation. Okay, so the line x equals to 0 and x goes to 5, we call it as asymptote for fx and gx respectively. All right, so again, if you want to find out the domain and range by using the graph, right, so you have to make sure that you know how to draw the basic shape of the graph. Okay, Right, so there's no example for this part also. Let's continue to search function. So for search function, this is a basic graph that we have. Okay, so this is the part where they actually teach you how to use the algebraic method to get the domain. All right, so again, for me, I don't think that this is very useful. I will prefer you to draw the graph again. All right, because for x, they want you to remember that anything inside the square root must be positive. Therefore, x must be greater than 0. Okay, then if you are having 3 minus 2x square root, then you must imagine that 3 minus 2x should be positive. If not, the function is not defined. Therefore, you're having 2x smaller equals to 3, and then the x smaller equals to 3 over 2. This is how they ask you to find out the domain. Okay? All right, so again, for us, if we want to tally with what we learned before, so we just focus on our transformation of graph. All right, okay, so all these are basic knowledge and shapes. And then how are we going to use the transformation to find the range we roughly discussed already? So now we are going to learn something harder, which is piecewise function that involve all the big shapes that we learned before. Okay, and also we need to discuss something here. All right, I will discuss it with you. Okay, so for piecewise function, okay, piecewise means that they are having different pieces of the number line. Okay, so they want to sketch the following piecewise function and state the range of the function. Okay, all right, so let us start. There are two graphs here, right? So maybe I will discuss the first one first later. Okay, so I put it like that. Okay, so when you want to draw the piecewise function, generally I will tell students, you look for the, maybe you can sketch the x and y axis first, if you want. Okay, so you look at the domain here, you have two parts of the graph. The first part is x smaller than 0, another part is x greater equals to 0. Maybe if you want, you can sketch a graph for x greater equals to 0 first. So for x greater equals to 0, you need to draw the graph x plus 5. Okay, so when y equals to x plus 5, right, and x is greater equals to 0, first value, maybe you can substitute 0, x equals to 0 into the equation. Okay, then you have 5, y equals to 5. All right, and after that, you can substitute any value larger than 0 because this is greater than 0, right? So you can substitute 0 and any value more than 0. So maybe you can substitute 1. So when you substitute 1, your y is equals to 6. So you can start plotting the graph. So this is 5. Okay, so let's say this is 1 and then this is 6. Then when you sketch a graph, your graph looks something like this. It is a linear graph, right? So it should keeps on going up. Okay, then how about for the smaller than 0 one? Maybe for the part smaller than 0, I will use the other color. You can see the difference. Okay, so for x smaller than 0, you need to sketch negative x squared. Okay, do you still remember how to sketch negative x squared? So you just imagine, originally you are having x squared. X squared is a U shape like this. And after that, if you want to sketch negative x squared, so you have to reflect it through the x-axis. So all this we learned before in the previous video. Make sure you already have the idea how to do it. Okay, so now this is my graph. And then this whole graph, okay, so this whole graph, the whole N shape is for y equals to, is for the domain. X can be any real number. All right, so this whole part of graph is for x can be any real number. But for this example, you only want to consider the part for x smaller than 0. So x smaller than 0 means here, correct or not? Okay, so this part is x smaller than 0. This part is x greater equals to 0. So when you draw the graph, you should ignore the x greater than 0 part. You should only consider the smaller part here. All right, so when you want to put it into our function, and because there's no equal sign at 0, right? So you put a white circle and then you draw the graph like this. Okay, so this is the part for x greater equal to 0. This is the part for x smaller than 0. So no equal sign. Therefore, you put your starting point as a white circle instead of the black dot. Okay. All right. So after you sketch a graph already, again, the way that you sketch a graph is not important. All right. They won't give you any extra mark for that. So they will only look at the graph. Let's say they want you to draw. Okay. After you complete the graph already, you should look for the range. All right. So for the range, you see that you got two parts of the graph. This is the first part of the graph. And then this is the second part of the graph that starts from 5. Okay, so for this part of the graph, the range is what? Y smaller than 0. And for this part of the graph, you will see that the y is greater equals to 5. Therefore, you can write out the range. Okay, so y is smaller than 0 and also y greater equals to 5. All right, so this is how we actually draw it. Okay, so I hope that you know roughly how to sketch the piecewise function correctly. You have to look at it part by part. Okay, then now example 7 part 2. Okay, so for example 7 part 2, when we look here again, so we are having two parts of the graph. All right, so again, usually I will draw the line first to let me know roughly. Okay, and then maybe I assume that this is the line. Okay, for 1, x. So x smaller equals to 1, you need to draw square root 1 minus x. X greater than 1, you need to sketch this. Okay, so let's talk about how to sketch square root 1 minus x. Okay, so this is very important because in the previous video, right, I didn't discuss one particular part with you. Okay, so maybe you can have a look again. Let me have a look. When we talk about f negative x, right, is a reflection of the graph through y-axis. This is what we did in the previous video. You download another file and then you draw the graph one, right? Draw all the graph. And then in the video, I think I asked you to write out something like this also. When f is negative, x minus a, it is a reflection. Sorry, a reflection of the graph through the line x equals to a. Actually, these two are having the same concept, just that for y-axis, it is actually x equals to 0, but it's right as y-axis. Okay, but now if let's say your negative is inside the basic shape and also have a line like this x minus a, then generally it reflects, okay, left, right also, but it is through the line x equals to a. Okay, so we didn't discuss this one, right? So we are going to apply it here. Okay, so now let's have a look at how can we sketch square root 1 minus x. Okay, so to sketch square root 1 minus x, generally you need to take out the negative and you make it become x minus 1. Okay, so these two are the same thing. So that means eventually you want to draw this graph. Okay, I want to draw this graph, remember. Okay, so maybe I put it beside first. Okay, so this is a graph that I want to draw. Right, so now, to draw this graph, first I know that my basic shape is square root x. So how will square root x look like? So it will become something like this. Okay, then the next step is what? So the next step is you need to sketch x minus 1 first. Okay, so when you put the negative 1 inside the basic angle, generally what you need to do, you need to move your graph 1 unit to the right. So when you want to do it 1 unit to the right, means that you are having 1 here and then your graph is still going to the right like this. Okay, then for the next step, if you want to sketch square root, negative x minus 1. So you want to sketch the graph square root negative x minus 1. So you multiply a negative inside the basic function, right? So suppose you should reflect it through the line y-axis. If let's say there's no negative 1 here, but now you're having the negative 1 here, that means when you want to reflect your graph, okay, so this is your negative, this is your 1, this is your original graph. So when you multiply the negative here, that means you need to reflect it through this line. So it will become something like that. So this is the mirror. Because they said reflect through x equals to a. So for this example, it will be reflect through x equals to 1. So if original graph looks something like this, when you reflect it, it will become something like this. Okay, so this is your final graph for square root negative x minus 1. So some students will ask me, do I need to do it like this? So this is the only way that you want to sketch your graph correctly, right? You have to make sure that when you sketch your graph, your basic shape in front always start from 1. It cannot start from negative 1, it cannot start from negative 2 or whatsoever. Right, you must put it under the pattern of 1. I understand that this is a bit, how to say, a lot for you to learn, okay, but all these are very small details that we seldom realize it. Okay, but no worry, from time to time when you learn more, then you will know more about all this. Okay, but I am just reminding you first. If let's say when you want to draw any graph, right, in front of the x, you have to rephrase it become 1x. Then only you can draw the graph correctly. Okay, all right, so if let's say I already know that my final graph looks like this, generally I will draw it. So this is my square root 1 minus x for this part. Okay, so I'm done with the first part already. Then now we want to go for the right hand side one, x greater than 1. So how to sketch a graph x greater than 1? Alright, so to sketch a graph x greater than 1, what I need to do is, again, this is the basic shape that I have, right? Oh, sorry, this is the x squared minus 1 that I have. Okay, so I need to start with basic shape, which is x squared. So x squared means a U shape. And after that, they want you to sketch x squared minus 1. So the minus 1 is outside the x squared, which is outside the basic function. Therefore, when you sketch it, you need to move your whole graph down 1 unit. Okay? And after that, I want to know what is the x and the x-intercept, or I want to know what is the root. So I let x squared minus equals to 0. When you try to solve it, you will have two values. One is negative 1, another one is positive 1. So that means on these 2 points here, you're having negative 1 and also positive 1 here. Okay, so this is the graph of x squared minus 1. And then if you look at the domain here, so what is the part of the graph that they want to consider? They only want to consider for the part x greater than 1. Where is x greater than 1? This is 1, right? So the graph of x greater than 1 is only this part. This is the U shape that you want to consider. So your final answer should be something like this only. Therefore, when I want to sketch a graph here, I'll sketch it like this. So you can have a look here for the right hand side, sorry, left hand side. The blue color one is square root 1 minus x. And then for the red color one is y equals to x squared minus 1. Okay, so you can see that all the graph here, when you want to sketch it or whatsoever, right, you still need to know how to transform the graph correctly and also how to interpret the domain correctly. Okay, so this is what we call as piecewise function. And again, can anyone tell me what is the range for this graph? So I think very obvious. The range here is y greater equals to 0. Okay, so hopefully you have the idea, right? Although we draw many graphs for these few videos here, but all these are not the main point yet. All right, because the exam style question, usually they will not ask you very straightforward like this. They will ask you to interpret more from the question. All right, so all the graph, all the example here are to prepare you to answer the harder question in the exam. All right, so you might find out that, okay, why I need to learn all this, because all the methods here, when you write out in the exam, they will not give you any marks. But it is to help you to understand the graph better and also to identify the range in an easier way. All right, so from now onwards, please make sure that you practice more. Okay, when you look at the quadratic equation, how the graph look like? Okay, when you look at the piecewise function, okay, how will the graph look like? Okay, spend some time to figure it out, to learn it. All right, so that in the future, when you want to apply it, it will become much more easier. All right, okay, so this is what we have. Okay, so we'll continue with the other parts for the function in the next video. Because for the function, we still need to know how to get the opposite function, how to get the inverse function and everything, and all those will involve all the domain and range, which is quite complicated for some of the part. All right, so for now, it's just the beginning for the domain and range. Make sure that you try to understand as much as possible. All right, for the graph, for the domain, and for the range. All right, okay, so we'll discuss more in the next video.